Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook, this one question lost more marks than any other on last year's paper. A student wrote down x squared plus 6x plus 5 and left it as it was. No method, no neat form, and they missed 2 marks. If they'd completed the square, the answer would have been immediate and the marks would have followed. Sound familiar? You're not alone, and by the end of this episode, you won't be.
The concept starts simple. Completing the square turns ax squared plus bx plus c into a bracketed vertex form that looks like a times, then a perfect square plus a constant. For the simplest case where a equals 1, say x squared plus 6x plus 5, here's the idea. We focus on the x squared plus 6x part because that's what makes a perfect square. Take half the middle number, half of 6 is 3, and square it to get 9. So we add and subtract 9 inside the expression, which keeps the value the same. Why add and subtract the same number? Because we're reshaping the expression without changing it. We create a perfect square inside the line and keep balance by cancelling the extra.
Let's do that out loud. X squared plus 6x plus 5 equals x squared plus 6x plus 9 minus 9 plus 5. Group the first 3 terms. That's x squared plus 6x plus 9, which is a perfect square and becomes open bracket x plus 3 close bracket squared. Then combine the constants. Minus 9 plus 5 is minus 4. So the whole expression becomes open bracket x plus 3 close bracket squared minus 4. That tells you immediately the vertex, the turning point, is at x equals negative 3 and the minimum value is minus 4. That is the payoff, a neat form and direct information about the graph.
Now, most exam questions aren't always as nice as a equals 1. If a isn't 1, factor it out first from the x squared and the x term. Take 2x squared plus 8x plus 3 as an example. Factor 2 from the first 2 terms to get 2 times open bracket x squared plus 4x close bracket plus 3. Inside the bracket, we complete the square. Half of 4 is 2. Square that to get 4. So we add and subtract 4 inside the bracket. 2 times open bracket x squared plus 4x plus 4 minus 4 close bracket plus 3. The x part becomes 2 times open bracket x plus 2 close bracket squared. Then distribute the 2 across the minus 4 to keep balance. That produces minus 8. Combine the constants outside and you have 2 open bracket x plus 2 close bracket squared minus 5. Remember, when you factor out a, any small constant we add inside the bracket is effectively multiplied by a on the outside, so always adjust the balancing term accordingly. That's the step students trip on most.
Why does half the middle number work? Think of expanding open bracket x plus m close bracket squared. You get x squared plus 2mx plus m squared. The 2m is the middle coefficient. So to reverse that, you take b, half it to get m, and m squared is the thing you need to complete the square. It's algebraic undoing, not a trick, but a structural reversal of expansion. Let that sink in. It's the same idea whether the numbers are integers or fractions.
The exam technique. Here's how marks are awarded on a typical 4-mark question asking you to complete the square and give the turning point. Mark 1, M1, is for showing the correct rearrangement or factoring out a if needed. Mark 2, M1, is for adding the correct square term and keeping the equation balanced. That means showing the added and subtracted piece or showing the adjustment after factoring. Mark 3, M1, is for rewriting as a bracket squared with the correct constant outside. Mark 4, A1, is the final answer, the vertex coordinates or the completed square expression. So even if you can't finish the final arithmetic, write every intermediate step clearly. Examiners give method marks for that work.
Common traps to avoid. 1. Forgetting to balance when you add a number. 2. Neglecting to factor out a when a isn't 1, and then losing a factor on the constant. 3. Sign errors when simplifying the constants. A typical student error is to write x squared plus 6x plus 9 as x plus 3 squared, but then change minus 9 plus 5 into plus 4 by mistake. A simple sign slip that costs the A1. Write the balancing step explicitly. Add 9 and subtract 9, or show the subtraction outside the bracket clearly. Teachers encourage underlining the added and subtracted numbers so they can't be lost under exam pressure. Now, the quick win, a 2-line 10-second check you can use every time. After you complete the square, do one of these 2 fast checks. A. Expand the bracketed square quickly to recover the x squared and x terms. Your x squared coefficient and x coefficient should match the original. Or B. Substitute the vertex x coordinate back into the original expression to confirm the y value. For example, with x squared plus 6x plus 5, we found the vertex at x equals minus 3. Plug x equals minus 3 into the original. 9 minus 18 plus 5 equals minus 4. That matches the completed square's constant of minus 4. If both checks match, you're almost certainly correct. This catches sign slips and missing brackets in about 90% of exam errors.
Make this a ritual. After you write your completed square, do the quick expand or the substitution. It takes 10 seconds and can save you 2 marks. That is literally the difference between a grade boundary for many students. Don't skip the check. Write it down so the marker sees your verification. It shows confidence and methodical working.
Extension and application. When should you use completing the square? Use it when the question asks for the turning point, the minimum or maximum, or when you need to sketch the graph quickly. If you need exact vertex coordinates, or to rewrite a quadratic for inequalities, completing the square is often faster and clearer than the quadratic formula. Use factorising when the quadratic factorises cleanly and you only need roots. Use the quadratic formula when factorising is hard and you need exact roots. As a quick application, suppose the area of a rectangle is given by a of x equals x squared plus 6x plus 8, and you want the minimum possible area. Complete the square to get open bracket x plus 3 close bracket squared minus 1 plus 8. Actually, that simplifies to open bracket x plus 3 close bracket squared plus 7, so the minimum area is 7 when x equals negative 3. That kind of reasoning appears often in optimization parts of real-world questions.
Before we close, a quick worked example recap you can copy into your exam script. Write, complete the square, x squared plus 6x plus 5. Step 1. X squared plus 6x plus 5 equals x squared plus 6x plus 9 minus 9 plus 5. Step 2. Equals open bracket x plus 3 close bracket squared minus 4. Turning point, x equals negative 3, y equals minus 4. Show the balancing step and box your final vertex coordinates. That's where the marks are. Write it down, don't just think it.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a printable checklist for completing the square at jcacademyonline.co.uk. The link is in the show notes. Visit the site for downloadable practice sheets and step-by-step solutions that match what we do on the show. Stay curious.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.